Hello, this is Grant Williams again for a presentation today on databases. In a quick overview of what I'll be covering in this presentation today, I'll start by explaining what a database is and the different types that exist. And then I'll introduce PostgreSQL and give a brief technical overview of how it works. Next, I'll walk through the installation and setup process on a Linux system and discuss common security risks that databases face. And then from there, I'll highlight some of Postgre's default configuration weaknesses and share 3 hardening recommendations to make it more secure. And then finally, I'll wrap up with a short conclusion and my references. What is a database? A database is basically the foundation for how digital systems handle information. It's where data is stored in an organized way so it can be quickly accessed or updated when needed. For example, when you log into a website or make an online purchase, the information that is being pulled from or written into a database. Databases make it possible for systems to manage large amounts of information efficiently, whether it's for tracking customers, processing payments, or storing app data. Without them, most of the software and online services that we use every day simply would not function. Types of databases. There are several main types of databases, each designed for different needs. Relational databases like PostgreSQL or MySQL organize data into tables and use SQL or SQL to manage and query that data. They're great for structured information that fits neatly into rows and columns, and NoSQL databases, on the other hand, are used for unstructured or flexible data like social media content or IoT data, Internet of Things. They include document based and graph databases, which are better for handling large, evolving data sets. Hierarchical databases store data in a tree structure. This model was popular in older systems where data relationships were very one directional. And then finally, network databases expand on that idea by allowing more complex, interconnected relationships between records. Though they're less common today, they influence modern relational and graph systems. Introduction to PostgreSQL. PostgreSQL is a powerful open source relational database that's known for reliability and performance. It runs default on port 5432 and uses the TCP protocol to establish stable and secure connections between clients and servers. One of its biggest strengths is that it's fully compliant with SQL standards, SQL standards, meaning it can integrate easily with other systems and follow consistent query structures. Beyond traditional relational features, Postgre also supports JSON storage, indexing, and replication, making it flexible enough to handle both structured and semi-structured data. It's also cross-platform, so it works well on both Linux and Windows environments, which is what makes it a popular choice for developers and organizations of all sizes. Now, a technical overview. Postgre relies on 2 main configuration files to control how it operates. The first one, PostgreSQL.conf, is where system level settings are defined, things like performance tuning, logging, and connection limits. The second, PG_HBA.conf, is one of the most important for security. It controls who can connect to the database, where they can connect from, and how they must authenticate. A few parameters are especially critical for setup and security. Listen_addresses determines which IPs the database listens on. Setting this carefully helps limit access to trusted hosts. Port defines which network port Postgre communicates through. By default, that's port 5432, and password_encryption decides how user passwords are stored, which is important for preventing credential theft if the system is compromised, and together these settings form the foundation for both functionality and database hardening. Okay, here's installation. PostgreSQL on Linux is straightforward and only takes a few steps. So you start by running the command sudo apt install PostgreSQL, which downloads and installs the database service. And then once installed, the main configuration files are stored under this pathway. And then the PostgreSQL.conf file controls the database's overall behavior, including performance tuning and logging, while pg_hba.conf sets the authentication rules and determines which users and systems can connect. After making any configuration changes, you will need to restart the service by using sudo systemctl restart PostgreSQL for them to take effect. Postgre listens on port 5432 by default, but you can modify this if needed. It's also important to remember that Postgre doesn't enable encryption automatically. You have to manually configure the SSL or TLS for end-to-end data protection. Common security risks. These are some of the most common security risks found in PostgreSQL deployments. The first issue is weak or default credentials. Like administrators sometimes forget to change default ports or use simple ones, which makes it easier for attackers to gain access. And then next is port 5432 being exposed. This is Postgre's default port, and if it's left open to the public internet without firewall restrictions, it becomes a visible and easy target for automated scans and brute force attacks. And then another risk is unencrypted client-server communication. If SSL or TLS is not configured, any data transmitted, including usernames and passwords, can be intercepted by attackers on the same network. Finally, overprivileged accounts pose a serious threat. Giving users more permissions than they need increases the risk of data leaks or accidental configuration changes. Following the principle of least privilege helps keep access secure and controlled. Default configuration weaknesses with PostSQL. By default, PostgreSQL isn't configured with security as the top priority. It's designed to be functional out of the box, which leaves a few weaknesses. First, Postgre may listen on all available interfaces, meaning anyone who can reach the system's IP could potentially attempt to connect. It's safer to restrict it to local host or specific IP addresses using the listen_addresses setting. Second, password encryption defaults to MD5, which is considered outdated and vulnerable to hash cracking. Modern setups should switch to a stronger options like SHA-256 for better protection. Third, SSL/TLS is disabled by default, so data between the client and server isn't encrypted unless manually configured. This makes it easier for attackers to intercept sensitive information if connections happen over unsecured networks. Finally, Postgre automatically creates a superuser account called PostgreS. If left unchanged or poorly protected, this account becomes a high-value target. Renaming it or securing it with strong credentials is a critical first step. Here's the hardening recommendations now. One of the most important ways to harden PostgreSQL databases is to limit who can reach it in the first place. The first step is to bind the service only to trusted IP addresses. By default, Postgre might listen on all interfaces, which could allow unwanted external access. And in the correct configuration file, PostgreSQL.conf, the listen_addresses setting should be restricted to local host or specific IP addresses that need to connect. Next, it's crucial to use a firewall to control inbound traffic. This means only allowing traffic from known hosts or internal subnets that legitimately need database access. Even a simple firewall rule can block most automated scans and brute force attempts. And then finally, reduce exposure on the port 5432. Many attackers scan specifically for this port, so it's best to restrict it. Use NAT or VPN, tunneling for access, or even change it to non-default port when possible. These basic network layer controls go a long way in preventing unauthorized connections before an attacker can even reach the database. And then hardening recommendations 2. This recommendation focuses on strengthening authentication and limiting user privileges, 2 major parts of keeping a database secure. First, use Scram SHA-256 instead of MD5 for password encryption. SHA-256 offers modern, stronger hashing and adds an extra layer of protection against brute force and replay attacks. This can be enabled in the Postgre SQL conf file under password encryption setting. Next, follow the principle of least privilege. When assigning user roles, each user should only have the permissions needed to perform their specific job or role, nothing more. And so, for example, application accounts shouldn't have admin or super user access. This will minimize damage if an account is compromised or query goes wrong. Lastly, configure pg_hba.conf carefully. This file controls how clients authenticate, such as requiring password-based authentication, local socket connections, or SSL. Make sure insecure methods like trust or ident are not used in production. And overall, combining strong encryption with strict access control dramatically reduces the risk of unauthorized database access. Hardening recommendation number 3. Postgre doesn't encrypt traffic by default, so one of the most important hardening steps is to enable TLS/SSL for all database connections. To start, you'll need to enable SSL in the Postgre SQL.conf file by the setting SSL equals on. This tells Postgre to use encrypted connections instead of plain text. Next, you must provide a certificate and private key, and these files will allow the server to prove its identity and establish a secure connection with the client. Similar to how HTTPS works on websites, ideally these certificates should come from a trusted internal or public certificate authority, not self-signed ones. Then in the pg_hba.conf file, you can require SSL for connections by using the host SSL keyword. This ensures that even if someone tries to connect without encryption, the request will be denied. And finally, enabling TLS SSL means that all communication between clients and the database, including credentials and data, is encrypted in transit. And this will protect against eavesdropping and man-in-the-middle attacks, especially when the database is accessed remotely or across multiple systems. To wrap things up, PostgreSQL is a highly capable and widely used database system, but its default setup prioritizes usability over security. By default, port 5432 is open, passwords may be weak, and data transfers are not encrypted, all of which leave the system vulnerable to unauthorized access and network attacks. The first key takeaway here is that Postgre needs to be hardened before deployment in any production environment. The first step is to restrict network access, ensuring only trusted IPs can connect with the database and using firewalls to block everything else. Next, apply strong authentication and least privilege principles, for example, using Scram SHA-256 for password encryption and limiting account permissions to exactly what is required. And finally, enable TLS SSL encryption on port 5432 to secure data in transit, preventing interception or tampering between clients and the database. Now, by applying all of these steps, administrators can perform PostgreSQL from a basic open configuration into a secure, hardened system, which would be ready to protect sensitive organizational data. And here are my references, and I hope you guys enjoyed. Have a good one.